Viewers like you make this program possible. Support your local PBS station.
It's one of the largest organs in your body. You can't live without. Yet many people desperately want to lose their fat.
But fat's been given a bad rap. We think of fat as being an evil substance. But fat is life.
Fat is critical to our health. It is releasing a whole host of hormones important for our bones, for our brains, for our reproductive organs. Fat is actually a very sophisticated endocrine organ.
For millions of years, people who were able to hold on to their fat had a selective advantage. And now all of a sudden, we've asked people to get rid of their fat. But our bodies never evolved to do that.
So what happens when we have too much fat?
Diabetes, cholesterol issues, heart issues.
It just sneaks up on you. It's like smoking cigarettes. It kills you slowly. You don't feel the pain.
I was aware that I was gaining weight, but I didn't know what to do about it. I'd follow every single thing my mom would say. I'd exercise for literally an hour daily.
Do we control our fat, or does it control us? Scientists are finding hormones and genes that act on the brain to influence our size and shape.
And those biological processes are well beyond willpower.
The implications are huge.
Obesity is the #1 chronic disease that we're dealing with.
How can science weigh in on our weight problem?
The pieces are starting to fall together. Signals coming from the body, the brain, and the genes. It's very complex, but that's exactly what you would expect for a system which is so critical to survival.
The truth about fat. Right now on Nova. This is Hiroki. Weighing in at around 550 pounds, he's about to take on Yama, a 2-time winner of the Sumo World Championship. Yama is the heaviest Japanese man in history. Overeating is part of his job.
Everybody say Yama!
While an average man eats around 2,500 calories a day, sumo wrestlers consume up to 10,000. Because the heavier you are in sumo, the harder it is to take you down. For years, doctors wondered why sumo wrestlers, who stay active, rarely suffer from conditions triggered by obesity. Answers would come as new insights radically changed our views of fat.
Most of us think of our fat as our enemy. It's not, it's our friend. We need our fat to store any extra calories so that we can use them in the future, to keep our heart beating, to keep our brain working. And what we've been learning over the last 20 years is that the fat cell isn't just simply a storage organ. It's a highly intelligent cell talking to our brains.
So why did body fat evolve in humans? To understand the forces that shaped us, a team of scientists have come to Tanzania. They've set up camp near some of the last hunter-gatherers on Earth, called the Hadza.
The human lineage is 7 million years old, and for the last 2 million years of it, we've been hunting and gathering. That's the key innovation of the human species. And the Hadza are a modern population, but they keep their old traditions still very much alive. And so this landscape and this lifestyle is a really good window into our own past.
For over a decade, Herman Poncer and Brian Wood have been studying the lifestyle and diet of the Hadza people to see what it might teach us about modern diseases.
The Hadza are great models in public health. They never get heart disease. They never get diabetes. They're not obese or overweight. And the diseases that we're most likely to die from in the US and Europe are not an issue with the Hadza. If we look at the Hadza's level of physical activity, it certainly is quite high when you compare it to Western sedentary societies. They cover more land per day in their travels. They spend more of their day moving around. And we know that high levels of physical activity are certainly protective against major sources of mortality.
With no livestock or crops, Hadza men and women must forage every day. Bahati digs for tubers, rich in carbohydrates and fiber, while other women collect fruit and baobab seeds. Boys scramble up trees to find bees' nests and harvest their honey. But the richest source of calories, and the hardest to acquire, are the meat and fat of animals.
Hunting is a risky endeavor, and that's one of the biggest gambles that you have to take in this foraging economy, is you have to get up in the morning and go hunting knowing full well that the odds are against you.
Hadza hunters, like Dofu, use poisoned arrows to shoot their prey. But the chase can take hours.
Hunting and gathering takes energy, a lot of it. And so 2 million years ago, we start burning more calories, we get bigger brains. But the catch is that that puts us at risk of starving to death. Because if we're burning our engines hotter and faster, then there's that risk that you're going to run out of energy. And so we've evolved fat as the safety net.
When a man has been lucky enough to kill a large animal, the first thing he usually does is to pinch its skin and to see how much fat is on it, because that's such a key motivator for their hunting. And there is no other species that extracts fat as efficiently from the landscape as we do.
Our body breaks down food into two main sources of energy, glucose and fat. Glucose provides immediate fuel or can be stored as glycogen in our muscles or liver. As glycogen is depleted, the body burns fat, which yields per pound twice as many calories. And while humans can only store about a day's worth of glycogen, we have enough body fat to survive for weeks. So think of fat as our battery.
One of the big misconceptions about human evolution is that we evolved to be healthy. And the answer is not really. The only thing that natural selection cares about is how many offspring you have who survive and then produce their own offspring. So our bodies are beautifully adapted, exquisitely adapted to take any excess energy and turn it into fat. Not because it makes us healthy, but because it helps our reproductive success.
Fat has long been revered. One of the earliest representations of obesity is a statue carved by hunter-gatherers. Scientists have speculated that this voluptuous figure symbolized fertility.
Over the centuries, we've had a wide range of views of what the optimal body shape and the optimal body fatness is, right from the Rubenesque period through to the flappers of the 1920s and the heroin chic of the 1980s. So across time, our views of what is an attractive amount of body fat has varied enormously.
Today, as we have stigmatized obesity, we have demonized fat. But the ability to be able to store fuel so that you can get away from your food supply for extended periods of time allows you to engage in complex behaviors and the development of the complex cultures that humans have. So fat is a feat of evolution. It frees us from the tyranny of having to eat continuously.
Fat cells, called adipocytes, look like bulbous spheres beneath the microscope. Inside are droplets of triglycerides, fats that our body can burn to release vast amounts of energy. Luckily, fat cells can expand far beyond their normal size to safely store our excess energy. So what would happen if you didn't have any? Troy Fryer has less than 2% body fat. Although he looks extremely fit, it's the lack of fat that makes his muscles stand out. With no padding on his face, his cheeks look sunken and his eyes are deeply set.
How far are you off that way?
The little bit of fat on my body is behind my eyeballs and on my liver. So walking around not having fat, it feels like constant needles are poking through the bottom of your shoe.
You know, some of us stand up all day and we're okay with it. Troy's not, because he has no padding on his feet, nothing in between his knees. There's no comfort at all. It's just unbelievable to watch him struggle.
Troy was born with a normal amount of fat. But by age 6, he began rapidly losing weight, despite having a voracious appetite.
I would go through 2 or 3 loaves of bread in one day, making 10 sandwiches at a time. So I would keep eating and eating and eating until it would hurt. And if I didn't get that food, I would get really upset and really angry. I would rip doors off their hinges.
I actually sent him in for a psych evaluation thinking that there was something wrong because he couldn't take the answer no. It's like he was starving.
By age 9, Troy was clearly ill. Doctors were shocked to find that his blood was full of fat and cholesterol, symptoms typical of obesity. It made no sense until Troy was diagnosed with a genetic disease called lipodystrophy.
We always think about thinness as something good, but in generalized lipodystrophy, it's beyond thinness. It's actually absolute lack of fat under the skin. So the excess energy doesn't have a place to go.
And that's why Troy was sick. With no fat tissue, excess calories collected in his liver, enlarging and inflaming it.
And when it got to that point of the doctor saying there's nothing else we could do for you, Troy turned to the doctor and said, so how and when am I gonna die?
Salvation would come from the discovery of a mouse that also couldn't stop eating. But unlike Troy, this mouse was fat, not thin. A genetic mutant from a breeding experiment, it was nicknamed OB, for obese.
This mouse had a defect in a single gene. And the impact of that gene was a mouse that weighed 3 times normal and had 5 times as much fat, and that overate voraciously. And genetics is very powerful because what it tells you is that obesity has a biological basis. What that basis is required identifying the gene.
Scientists began to hunt for the mutation that made the mouse obese, combing through the 2.5 billion letters of its genome.
Think of it as an alphabet. You spell out letters of the genome. There are 4 letters, A, G, T, and C. These spell out indirectly proteins, and a single spelling error can lead to a defective gene.
In 1994, after a decade of work, Friedman and his collaborators homed in on a gene only found in fat cells.
That was really the moment of a lifetime. I pulled out the film with some vague hope that maybe this would reveal something about the nature of the OB gene, and I looked at it. And in that instant, I knew that we had identified the gene that makes a hormone and that plays a very active role in regulating appetite, metabolism, and probably other biological systems.
So if you injected that hormone into the blood of an OB mouse, the mouse lost weight. It would completely cure the mutation of a OB mouse.
And over the course of a few weeks, depending on the dose you give, they'll look indistinguishable from a normal mouse.
The hormone was named leptin from the Greek word leptos, meaning thin. Its discovery transformed our view of fat and the biological forces controlling appetite.
The OB mouse cannot see itself in a mirror and realize that it's hugely obese. It thinks it's starving to death because this very critical hormone is not being made by the body. And the idea that a hormone produced by fat can control what you think about food in a very important way, this is a very radical notion.
Growing up on the outskirts of Chicago, Sana Mahmood never suspected hormones might be driving her hunger.
I just thought I didn't have enough willpower in me to control myself from food. No matter how much I'd eat, I was starving all the time.
From infancy, Sana was overweight. Her parents thought she would soon lose her baby fat, but she only grew heavier.
I'd exercise for an hour daily, doing like kickboxing or treadmill or just being as active as I could. But I didn't know what was going on and I was getting scared and I would pack on like 10 or 20 pounds in a month.
As Sana struggled with obesity, she sought help from Dr. Lisa Neff.
Okay, come on in, Sana. Go ahead and have a seat. So this is what we call an indirect calorimeter. What it's going to do is measure how many calories your body is burning in a day. Just breathe normally. Sana had tried all different kinds of diets, exercise programs, medications for weight loss, and yet she had continued to gain weight. So the very first test that I did was a leptin level in her blood, and it was undetectable. So Sana has been fighting hunger her whole life, and it's because she's lacked this critical hormone.
Like the OB mouse, Sana has a mutated leptin gene found so far in just a few dozen people. A normal fat cell produces leptin, which travels to the brain and signals the hypothalamus, a region that determines when and how much we eat. High levels of leptin tell your brain you have plenty of fat stored. But low levels, or in Sana's case, no leptin at all, triggers an alarm to eat.
First of all, you get the hunger signal, but secondly, you slow down your metabolic rate. And if your leptin levels fall even further, your body says you're starving, and you do all sorts of things to preserve your life. You slow down your immune system. You turn off reproduction so that you can survive this period of starvation. So the signals coming from the body to this bit of the brain called the hypothalamus are really so powerful.
Sana is now taking leptin and has lost 40 pounds in 3 months.
After taking the leptin, I've noticed a huge change in my hunger. I can go 4 to 5 hours without eating anything and I'll be totally fine. When I think about the future now, I'm seeing clear skies everywhere. My confidence levels have soared.
And for those like Troy, who can't make leptin because they lack fat, getting the hormone would be life-saving.
The starvation was gone within 3 days of him taking leptin. We saved a lot of money. Troy went from eating what 3 people would eat to eating what a normal person would eat in a day. Got a little bit of blood on there.
Knowing that I was full, I'm like, wow, this is amazing.
Does it hurt?
Leptin can't cure Troy's disease, but by curbing his hunger, it protects his liver.
Leptin does not bring the fat back. It just helps to deal with fat's absence. Patients finally can take a deep breath that they're full and they don't have to worry about eating.
The discovery of leptin was so exciting, and the molecule entered into clinical trials in human beings, and we awaited the results of those trials with great anticipation because we thought at last we have something that's going to cure obesity in our patients. That turned out not to be the case.
Most obese people produce plenty of leptin, a lot of it. And in fact, what we found out is that giving more to people who have plenty doesn't have much of an effect.
While leptin couldn't cure common obesity, it revealed that fat was not just a reserve of calories, but a complex endocrine organ producing dozens of hormones.
And those hormones are important for our bones, for our brains, for our reproductive organs, for our muscles. They're important for everything. And through these hormones, fat can communicate with our bodies. It can communicate with our brains. So fat has different roles in our body at different times of our lives.
Especially at birth, when a human baby, on average, has the highest percentage of body fat of any species.
You know, humans really are by far the fattest ape. A typical human baby is about 15% body fat. A typical hunter-gatherer male is about 10 to 15% body fat. A typical hunter-gatherer female is 15 to 25% body fat. That's leagues beyond any primates.
Not only are we fatter than other primates, we also have bigger brains. And compared to its body size, a human baby's brain is massive.
And that brain is consuming half of that baby's calories, roughly. That's a lot of energy, right? And the baby can't stop feeding its brain. The brain doesn't hold on to energy. It's a constant, thirsty, demanding organ. And fat ensures that we always have energy available to pay for this thirsty organ. So when you see a fat, pudgy baby, that's a healthy baby, because fat is life, right? If you don't have enough fat, you're at risk.
As we get older, fat plays a role again because you need a sufficient amount of fat to have enough estrogen. Fat produces estrogen. In fact, girls have to gain, on average, about 13 pounds or so before they're able to initiate puberty.
Model Hartje Andresen never thought much about fat until she confronted the pressure to be thin.
Will you send me the picture?
The photographer who discovered me said, you know, you're perfect, you're beautiful the way you are, but if you get into the modeling industry, they are gonna tell you to lose weight. So my word of advice to you is don't do it.
But for many models, like Robin Lawley, that advice was hard to heed. Women who walked the runway had to wear size 2 or smaller clothing.
It was that heroin chic look at the time. So it would be girls of my height, like 6 foot, and a size 0. So you had to be emaciated to get that look. You literally had to starve yourself. And if you didn't do what you were told, you could be cut. So I tried, I lost a bunch of weight, maintained it all for 2 minutes, and then it all came back on again.
Hartje lost the weight an agency had requested, getting down to 100 pounds. But slowly, she began to realize that being thin was not necessarily healthy.
My hair had really bad quality, and my fingernails were really brittle. I would get cracked lips and sores at the corner of my mouth. But the point that made me realize that maybe I was getting too thin was when I started breaking my ribs.
Google starvation, and that's what happens. Like, you will lose your period. You will cause all kinds of diseases that you never thought would come to you.
When I was speaking to my doctor about wanting to have a baby, he actually warned me not to be any thinner. And even though I was exercising a lot, I was obviously not healthy.
if you don't have enough fat storage. One thing that is affected significantly is that we develop issues with bone, which can then lead to osteoporosis, so actual brittle bones that have a high susceptibility to breaking. And so that's something that people might not think about as we're looking for this aesthetics of getting to that twiggy, ideal body image.
At the other end of the scale are sumo wrestlers. Given their massive size, how do they avoid diseases normally associated with obesity? The answer lies in where they store their fat, safely underneath their skin, instead of in the abdomen or chest, packed around internal organs.
So if you do a scan of an active sumo wrestler, a CT scan or an MRI scan, you'll see all that fat, but it's on the outside. It's on the buttocks and thighs. It's on the outside of the abdomen.
So even though they have body fat, they don't contain a lot of fat in those deleterious places, such as the liver, around the heart, around the pancreas, and even around the kidneys. So they're metabolically healthy.
And the key reason is that sumo wrestlers exercise rigorously, up to 7 hours a day.
When we exercise, our fat releases a hormone called adiponectin. And adiponectin actually helps guide fats in the blood into safe deposits of fat. So they'll guide it into subcutaneous fat right under the skin. Interestingly, when sumo wrestlers come off of their exercise regime, they get metabolically unhealthy very quickly.
To maintain a stable weight, the number of calories you eat needs to match the number you burn. So many assume that losing weight is simply a matter of eating less and exercising more. But scientists are discovering that it's not so simple.
So what is astonishing is the fact that we ingest more than 1 million calories a year, and yet we don't oscillate between supermodel and an opera diva over the whole period of a year. We stay pretty stable.
So I think the best way to think about how weight is regulated is to think of it as a set point, right? That is, that our body is defending a very particular weight under a certain set of circumstances.
And it's obviously not set because the body weight can change. What is set is what is the minimum body weight for that individual. If you drop your body weight below this threshold, the body will begin to do whatever it has to do to prevent your dying of starvation.
But few Americans grasped just how hard the body fought against weight loss until a reality TV show called The Biggest Loser captivated audiences. One of the heaviest contestants on season 8 was Danny Cahill. For Danny, competing on the show was a shot at salvation, something he had longed for since childhood.
When I was a kid, I was like, if you could have one wish, what would you wish for? And, you know, most people say $1 million, you know, or something. I say, I wish I could be like that person that eats the same as me and seems to never gain weight.
As a child, Danny tended to be heavy, but by the time he was a father, he struggled with obesity. His doctor warned that unless he slimmed down, he might not live to see his kids grow up.
I was mortified at how big I'd gotten. And it seemed like it happened overnight. It just sneaks up on you. You don't feel the pain. So when you gain a half a pound and a half a pound and a half a pound every week, well, in a year, that's 30, 40 pounds, and in 5 years, that's 150 pounds.
Danny saw The Biggest Loser as a second chance.
Look at that word believe, okay?
Cutting calories and exercising around 45 hours each week, he hoped to shed a pound a day.
Let's go. Pop it.
I went there with a purpose. I went there to lose the weight. I went there to break a record. I went there to right my life and to get the weight that I'd been carrying around for years off of me.
As the season progressed, Danny pushed harder, cutting back to 800 calories a day. 7 months later, when he stepped on the scale for the final weigh-in, he had lost a staggering 239 pounds.
I was mentally exhausted. I was physically exhausted. In fact, looking back at it, I go, how did I do that? How did we do that? That is crazy.
Danny was determined to keep the weight off at home. He delayed returning to work so he could exercise several hours a day. When his book tour ended, he went back to his job surveying land. Moving less and feeling constantly hungry, the weight came back. Danny regained over 100 pounds, and he was not alone. 6 years later, NIH scientist Kevin Hall found that 13 of the 14 contestants he examined had regained much of their lost weight or were even heavier.
When you make extreme changes to your diet or physical activity patterns, your body responds very strongly, both in terms of slowing down the number of calories that you're burning, as well as increasing your appetite and hunger. And those types of processes that are biological are well beyond willpower.
Close the door.
Research has revealed that as dieters lose fat, leptin levels fall, triggering hunger. As Danny regained weight, his leptin levels should have rebounded. But did they?
You started out kind of more or less where you'd expect for your amount of body fat, but 6 years after the Biggest Loser, here's where you ended up.
And I was told that that would tell your body that you're starving and that you needed to eat. So how am I going to handle this being hungry all the time with my hormone levels out of whack? And is that ever going to correct itself?
Thyroid hormones also fell. And that's one reason, as contestants shed pounds, their metabolic rate, the number of calories they burn while resting, dropped.
What was the surprise was that 6 years later, their metabolic rate was still at the same level despite regaining all that body weight.
You started off at 0, basically.
And compared to other contestants, after Danny's weight rebounded, his metabolic rate had fallen the furthest.
Your metabolism was about 800 calories a day lower than what we would expect.
I was shocked. My body burned 800 calories less than a normal man that was the same height and weight. And I just want people to realize that obese people aren't just lazy people. There are a whole lot of things at play here, and one of them is our biology.
So the vast majority of humans fail on a diet. And from an evolutionary perspective, that makes sense because we never evolved to lose weight. As soon as you go in a diet, that activates what's called a starvation response to help us hold on to energy.
The brain remembers that set point. The brain is a powerful organ, and the hypothalamus is powerful in knowing what our weight was. And so the brain wins.
There's another reason why it's hard to voluntarily control your weight. It's obvious when looking at identical twins that the size and shape of their bodies, and even their gestures, are remarkably similar. That's because they share 100% of their genes. But that's not true for fraternal twins. They can differ in gender and size because they only share half of their genes.
So if you systematically compare identical to non-identical twins, what you conclude is that obesity is as or more genetic than any trait that's been studied with the exception of height.
These twin studies have shown that the heritability of obesity is around 40 to 70%. So obesity is not just about the environment, not just about your lifestyle. Your genetics determine why some people gain weight more easily than others.
To find genes that influence obesity, a global consortium is analyzing genomes at centers like the Broad Institute. Over 1,000 genes have been identified that may play a role in determining weight. Most are for common obesity and have small effects, but not all. The data, mapped to 23 chromosomes, is publicly available to scientists like Ruth Luce. As she homes in on a specific location, she can search for individual genes. To date, researchers have identified 8 different genes which can cause severe, early-onset obesity.
And most of these genes, they act in the brain. They control food intake, they control hunger, satiety, reward, basically components that we can think of as controlling willpower.
And there are other gene variants that don't cause obesity, but may make carriers heavier. One impacts leptin signaling.
If you carried that mutation, then you would weigh about 15 pounds more than someone who does not. And we see that 1 in 5,000 individuals in the general population carries that mutation.
But while genes can increase your risk for gaining weight, they can also protect you. One gene variant, found in about 6% of the population, makes carriers always feel full instead of hungry.
Now, this variant doesn't make you fat, it predisposes to making you leaner. So we need to understand that there are people who are very susceptible and people who are very resistant. That obese people are not morally inferior, they're biologically different.
Obesity is defined by your body mass index, or BMI, a calculation that divides your weight by your height squared. A BMI above 25 is classified as overweight, and higher than 30 as obesity. In the 1980s, obesity rates in the US began rising sharply, reaching higher than 39% in many states.
Obesity by far is the greatest public health challenge of our time. It is the #1 chronic disease that we're dealing with here in the United States, and it's leading to at least 100 different disease entities that we know of.
So we will never get ahead of diabetes, we'll never get ahead of cardiovascular disease, we'll never get ahead of cancer unless we address the root cause. And the root cause is, in many cases, obesity.
And it's not just a US epidemic. In just 3 decades, obesity nearly tripled worldwide. According to the World Health Organization, one problem might be a decrease in physical activity, causing us to burn fewer calories. So is one solution to simply be more active? Back in Tanzania, Herman Punzer and Brian Wood, working with a team of international scientists, hope to find out. They're giving members of the Hadza community GPS devices to measure how far they travel each day. The answer might shed light on why the Hadza don't suffer from the chronic diseases seen in the West.
Without antibiotics and vaccines, sadly, a lot of kids don't make it to their 15th birthday. But if you make it to 15 in the Hadza population, there's a great chance you're going to live to be in your 60s, even 70s and 80s, and with a much healthier body than we would often have in the West.
GPS data reveals why. Hunters, like Dofu, walk about 9 miles a day, while women foragers walk about 5. That's more exercise than the average American gets in a week. But do the Hadza people also burn more calories each day?
I had spent many months living with the Hadza. I had gone with them during the day of foraging and come back to camp, and I felt so tired and exhausted. I felt, of course, the energy use that we would be detecting would be much higher than in Western populations.
To find out, volunteers like Dofu drink a special water with hydrogen and oxygen molecules that can be traced. Over the next 2 weeks, by tracking the depletion of these molecules, the scientists can measure the number of calories burned each day.
So we come out here, we collect all this data, putting urine samples on liquid nitrogen, shipping them to one of the best labs in the country. And as the results came back, I wasn't sure what I was seeing at first.
77.
Despite being more active, Hadza men only burn on average 2,500 calories per day, and Hadza women about 1,900. The same amount as an average man and woman in the US.
It's a really counterintuitive result, and it really surprised us. Somebody who is sedentary, working a desk job in the US, is burning the same number of calories as a Hadza man or woman who is so much more physically active. And that's even after you account for things like body size, body composition, age, gender, all of those factors.
The research suggests that no matter what our lifestyle is, our body protects us by keeping the total calories burned each day within a narrow range. And that's why, in the long run, exercise alone won't make you thin.
I think what the Hadza data tell us is that we can change our lifestyles however we want, and more activity is always better. But it's not going to burn more calories because our bodies adjust to these more active lifestyles.
The implications are huge. If obesity is not due to sedentary lifestyles, it must be caused by eating too many calories. And according to Daniel Lieberman, that became possible as humans changed their environment.
So in the last 10,000 years, we've transformed both how we get energy actually and how we use energy. And the first big shift occurred with the origins of agriculture, when we shifted from simply going out and getting food out there in nature to growing the food ourselves.
Farming allowed humans to grow carbohydrate-rich foods, like corn, wheat, and rice.
And then we invented machines and industrialized how we grow food. We've increased the scale of calories that we produce by orders of magnitude. And the result is, for the first time in millions of years, we have more energy than we know what to do with.
And it's not just an excess of calories. Scientists suspect that obesity may be caused by the changing nature of the foods we eat. More than 50% of calories in the US are consumed in the form of ultra-processed foods. Low in fiber, but full of fat, sugar, and salt. Packed with calories, they've been labeled obesogenic. But do they cause us to overeat? To find out, Nora Volkov has been scanning the brains of patients with and without obesity.
To me, the most important aspect about obesity is understanding that the food itself has made changes in your brain that are driving your inability to stop eating.
These changes begin as food activates our brain's reward system, releasing a feel-good chemical called dopamine. Through pleasure, dopamine motivates us to find and eat rewarding foods. Imaging reveals that high-fat, sugary foods can overwhelm the brain's reward system, flooding it with too much dopamine.
Our bodies actually have evolved to try to maintain an homeostatic state, and that means that if there's too much stimulation with dopamine, you start to see that receptors that are sensitive to dopamine are downregulated, they decrease.
Volkov found that dopamine receptors, seen as red in the brains of control subjects, are reduced in people with obesity.
As dopamine signaling goes down, our capacity to be able to inhibit desires goes down. So I say, I'm not going to eat the chocolate, or I'm not going to eat the donut. I don't want to eat it. Can I stop it? And if those areas of the brain are not functioning properly, no matter how much you want not to do something, it's very difficult to carry through. And this explains why people will tell you, I did not want to eat the food. I knew I was going to gain the weight, yet I could not stop myself.
The truth about fat is complicated. Evolution has designed powerful hormonal and neural signals to ensure that we eat and defend our weight.
I think what people really need to understand about obesity is that it's not your fault. This is not a matter of your willpower. This is a disease. It's a chronic disease. It's a highly complex disease, and there are many causes of obesity.
So can obesity be prevented or treated? The experts say maybe, using a long-term approach focused on health.
I don't want to put you on the next diet. Diet implies that it's short term. I want to put you on a lifestyle plan that you can sustain for years.
While The Biggest Loser reveals why diets fail, contestants like Danny, who continue to exercise, kept off 10 to 13% of their weight. And medically, that's a success because modest weight loss has huge health benefits, from lowering blood pressure to preventing diabetes. There are also medications that signal the brain to feel full and help people lose 10% of their weight. And if you want to lose 100 pounds or more, there's another option. One that Muriel Mina chose to avoid the fate of her mother.
I was 3, and I remember she was talking on the phone, and she collapsed because she had a heart attack. And then I just remember EMTs rushing in.
At age 44, Muriel's mom weighed 300 pounds and had died of heart disease. As an adolescent, Muriel began struggling with her weight just as her mother had.
I was going to the doctors and having to get my heart checked, and I was like, wait, this is weird. Like, I'm 13 at a cardiologist. It was always in the back of my mind, oh, this is what she passed from.
By age 16, Muriel, like nearly 5 million American teenagers, had obesity and qualified for bariatric surgery, which bypasses or removes part of the stomach.
Bariatric surgery is the only way that most people with severe obesity can not just lose weight, but most importantly, keep it off. So you've been doing great. The first thing I want to show you is 275 was your highest weight. Your body mass index was 43. After surgery, you went all the way down to 172 pounds and a BMI of about 28. And that's really fantastic. Originally, we thought that bariatric surgery worked by making the stomach much smaller so that you couldn't eat a lot of food. We now know that the hormones that come from the GI tract and go to the brain change in the way that cause satiety earlier, sooner, and with much less food.
These signal changes between the gut and brain help the body reset its set point for years. But hunger can return because our weight is as regulated as our blood pressure and heartbeat.
The ability to control our weight is distinctly outside our conscious control. People don't like to hear that. We all want to think that we're in control of when we put the fork down. But there are lots of biological forces that are controlling what weight it is that you end up at.
Fat behaves differently on all of us. It has to do with our genetics, it has to do with our age, our gender, a whole host of factors. Everybody is very different. And what matters is to be healthy, not to be perfect.
Today, Hartje Andresen is 20 pounds heavier, a mother, and modeling on her own terms.
I had to overcome this fear of gaining weight, and that really took some courage for me. Modeling has the possibility to show people how a healthy body should look like. The focus needs to be more on strength and health rather than being a certain size.
And there's another insight provided by the Hadza and hunters like Dofu.
What the Hadza tell us is that diet and exercise are two different tools with two different jobs. You need to exercise to stay healthy and to age well. But you need to watch your diet if you want to watch your weight.
It's not a coincidence that the obesity epidemic is spreading around the world. Wherever modern, Western, post-industrial lifestyles show up, obesity follows with them. But I don't think the solution is to go back to the Stone Age. I think the solution is to learn from our evolutionary history and get the best of both worlds.
Be more PBS.